Yep, take it. We're gonna officially start in like 5 minutes. It is lesson 15, all, some, or no solutions, lesson 15. So my friends at home that are CVL students, please, until you get your textbook, you will be having to do them on the slides. So please open up the slides for today. Hi, everybody. Please open up your textbooks to lesson number 15, all, some, or no solutions. Please open up your textbooks to all, some, or no solutions. Hi.
Hey, when Tyler went to the math school this time, master Lego.
Is it an emergency? Fill out the form. Or fill out the form. Okay, we are going to get started. We're looking at lesson 15. Please close your textbook.
Excuse the interruption. If you are going outside for math breaks, please be sure to shut the door when you come back in. Thank you.
So I need everybody in textbooks opening up to page activity lesson number 17, all, some, or no solutions. I'm not going to be doing it in the book today. I'm going to be doing it on the slide, but you will be following along and doing it in your textbook. Okay, I'm going to get started for my people at home. I'm going to get started. So let's take a look at this warm up on slide. Well, actually, let's look at our learning goals. Our learning goals for today. Let's think about how many solutions an equation can have. So normally when we solve it, we get x is equal to some number. It can be a fraction, it can be a decimal, it can be a whole number, right? Now we're going to be looking at equations that might not have only one solution to it. You could be able to maybe plug in any number and it would solve it and it would still be correct. So let's take a look at number 3. Your warm-up activity 15.1, it says, which one doesn't belong? Equations. So, okay, so Kyle put his answer in. I want you to take 1 minute right now to decide which one does not belong and tell me why. In the space that you have in your book, you're picking one that does not belong, which one of the equations does not belong, and you're going to tell me why. Okay? We're going to take 1 minute to answer that question. What What do you mean Pilot doesn't have, or what do you mean Gabe doesn't have an answer? There, you're just picking anyone you think doesn't belong. There's no correct answer here. When I ask the question, which one doesn't belong? Remember, I'm not going to say that there's one correct answer. There might be a couple correct answers. As long as you justify your answer, which one does not belong? Wonderful. We're going to come back together in right now. Let me pull up the chat. Okay. So let's see what people think. Some friends at home. Gabe said number 4 doesn't belong, and he said the left would be -2 if you were to solve it, and the right would be +2. Okay, good, nice answer there. Connor said number 3 because both sides aren't equal. Good. What other one did you think, Adam? Number 4. What were you thinking for number 4? Why? Which one were you thinking then? Number 2, and why were you thinking number 2? Well, it's 5 times 7 and then 7 times 5. Those look like the same numbers to me. So what are you trying to say there?
Because it's 5 minus 7 is minus 7 minus 5.
So 7, because both sides are not going to be equal to one another. Good. So it wouldn't be a true statement. Good. So we're just thinking. We're getting ourselves thinking. When the first time I looked at it, I said number 3 because it has a 2 in it. It's the only one that has a 2 in it. So really, we could be saying anything for these ones here. Any reason could work for this, okay? So let's take a look at slide number, so the next section here. So this next section is not in your textbook, it's just on the slide. So let's take a look at this, stick onto the Zoom page for right now. So we're looking at these 2 equations. So we have 2t plus 7, or 2t plus 5 is equal to 2t plus 5. I want you to find a value of t that would make the equation true. Is there any value that doesn't work? So I want you to take 1 minute right now to decide. First pick a value that would make the equation true, and then figure out or think about, would there be any number that wouldn't make it true? We don't need our Chromebooks open, we just need our textbooks open, please. So Gabe said 5. Gabe gave an example of 5, okay? So this part isn't in your textbook, you're just looking up here and we're doing it together, okay? What's another value that could make it true? Ian, what were you thinking? 3? 3, okay. What were you thinking, Adam? 1? Okay. Actually, I'm going to give 1 a second. Max, what were you thinking?
7.
7? And then let's look at that second question. Is there any value that doesn't work? Ian, what do you think? No, there is no value that doesn't work because whatever we're doing, we're taking that same number, we're multiplying by 2, and then we're adding 5 to it. So every value is going to work there. Okay, so every value will work here. Now let's look at this second one down here. Find a value that makes the equation true here. Is there a value that would make this equation true? So Connor, try to substitute that in and see if it's still true. Connor said originally he said 0. So if I were to plug 0 in here and I said 0 plus 5 equals 0 plus 7, what would that equal to? What would that be equal to? 5 equals 7. Is that a true statement? No. So Connor changed his mind. He said 0 did not work. So 0 did not work. Connor changed his statement, so there are no numbers that would fit in here that would make this true. Do we agree? Max, what do you think?
I think there are none because it's addition, but I think maybe if it was a multiplication or division, there could be some.
So maybe if we like put like, but there's no like single number if we put it in there that would work. Good. No values would fit in here and make it true. Okay, so let's take a look at this next slide here. We're going to learn 2 different phrases here to give to equations that mean these 2 different things. So let's take a look at slide number 5. If you're working in your textbook, this isn't in your textbook either. This is just a sort of review page where we're learning a new concept. So there's 3 different answers that you can get when you solve an equation. You could get x is equal to 1 number. You can get x is equal to no numbers you would put in there would work. And we call that no solutions because there are no values that you can plug into the equation that would make it true. So that means the x values on both sides are the same, but the constants are different. So if we look at this example here, both sides have 5x, but our constants are different. I have a +4 on the left side and a +6 on the right side. So if we have an equation that has the same x value, so like for example, 5x or -2/3 x on both sides, but a different constant, we would say that it has no solutions because you can't plug any number in there to make it a true statement. Question.
I was going to say I kind of disagree because you can also have like, and so if it's like multiplication or division instead of addition, I think you could find numbers that would
Yeah,
work.
but then that would be a different equation. If it was 5x times 4 equals 6 times 5x, that still would get you, or 6 times 5x, it still would get you a different number. No number that you put in there would work. If you have the same x value on each side and a different constant, you're going to say it has no solutions every single time. Same x value, different constant is going to be no solution. Sort of now the opposite is the same here. Infinite many solutions. You have infinite many solutions if any number that you place into the equation or plug into the equation would make it true. So the x values in the constants are the same on both sides. So when you have the same equation or expression on each side, you're going to say it has infinite many solutions. The example I picked here was 5x plus 4 is equal to 4 plus 5x. We could also say 2x plus 2 is equal to 2x plus 4. So when you're looking at an equation, you might need to distribute before you decide if it has no solution. So when you're deciding if an equation has no solutions, many solutions, or infinite many solutions, you have to bring it down to x's and constants. You can't have parentheses, you can't have you can't have like divisions or like if there's divisions on both sides. So this you would have to distribute, and then you would see it's equal to 2x plus 4, which those are equal. Does that make sense? So you can't just look at it right away and be like, infinite many solutions. No. You might have to do a little bit of work first. Does that make sense? People at home can hear me, right? Throw it in the chat. Perfect. Thanks, guys. I'm just always really super self-conscious of that. So we have these new terms, no solutions and infinite many solutions. There will be a poster up tomorrow, up over there, that talks about no solutions versus infinitely many solutions. Okay? So these terms are not going away. Wonderful. So now we're going to be back in our textbook. If you have your textbook, I want you doing this in your textbook. We are going to decide, we're going to sort these equations into two types. Okay? We have true for all values and true for no values. So some of these, this n equals n, you won't have to do any work to because we already know our variables our x's on each side are the same and our constants are the same on each side. So we can, but for this one here, let me see. Like for this one right here, we might need to combine our like terms for this. Or for this one right here, we might need to distribute. So I want you to take 5 working minutes right now to sort all 8 of these, all 8 of these into 2 categories. True for all values, true for no values. Infinitely many solutions. Infinite solutions or no solutions. Does that make sense? What I'm asking you to do. Okay? So you're going to have to fiddle with some of these. You might have to distribute. You might have to combine like terms before you make these decisions. I'm going to come right over here in one moment. Why don't we just swap books? There is no page number, so it's lesson 15. It's all, some, or no solutions. So you might need to solve some. You might need to get a separate piece of paper and make some choices, do some math out to test them. Some of them are a little bit easier. Some of them you won't have to do any work for. I'm going to put a note. All right. One moment. Okay, so what we're going to do, I want us to pause for a moment, and my friends at home, what I'm going to do is I'm going to actually stop sharing my screen for a moment, and I'm going to stop sharing my screen, and we're actually going to take a mask break because I'm very hot right now, and I'm about to I'm very warm right now. So we're going to step outside, we're going to go down, we're going to take a mask break, and then we're going to come back up. Does that make sense? Because everybody can stay right in this chat here. I'm going to put everybody in the waiting room. I'm sorry about this, guys, but we need to just take a moment I'm gonna put you guys in the waiting room. I'm gonna come back in like 5 minutes to let you guys back in, okay? I'm sorry, guys, this is not how this is normally gonna work, but Mr. Main just needs a moment, okay? So let me pause the Zoom recording. Which ones did we think were no solutions? Ian, what was one that you said had no solutions?
I put the v plus 2 equals v minus 2.
Very good, v plus 2 equals v minus 2, and then I'm gonna call on Kyle and Gabe in a moment. So, Ian, why did you think the v plus 2 and the v minus 2 was one of them?
Because with the minus, you'll get like a smaller value than you would with the adding.
Good, because our variables are the same on each side, right? But our constants are, what are they? They're different, right? Because we have a plus 2 and we have a minus 2. Very good. Gabe said he chose, let's see another one that he chose. He chose the 1/2 plus x is equal to 1/3 plus x. Kyle, do you want to, or Gabe, do you want to unmute and tell us why you chose that one?
The constants are different, but the variables are the same.
Woo, woo, party hardy. Nice job. Awesome job, Gabe. Kyle, I'm going to come back to you for that other one in a moment. Can someone in here tell me one that they thought was true for all solutions? Max, which one were you thinking?
I was saying 2t plus 6 equals 2, and then t plus 3 in parentheses.
Good. Because if I were to factor this out, what would it factor out to on the right side?
2t plus 6.
2t plus 6 is equal to 2t plus 6. Awesome job, Max. That's perfect. Wonderful. Kyle said he thought the 3 parentheses n plus 1 is equal to 3n plus 1 was not one that was accurate. So this one right here. And Kyle, do you want to unmute and tell us why? Kyle said it doesn't work because the first side is 3, and the other side was 1. Very good. Because if you were to distribute this, 3 times n, 3 times 1, you would get 3n plus 1 plus 3 is equal to 3n plus 1, right? And we have the same variables, but different constants. Nice job, Kyle. Who in here can tell me another one that they thought was correct? Or was true for all solutions? Abby, did you find one that you thought was true for all solutions? Or do you want to test one out? Help me test one out?
Well, I had just the other 2 that are.
Okay, go ahead. Which one did you put where? Tell me.
I put the. Oh, wait, here we have that one. I don't know. Okay, I had 5 minus 9
Yep.
plus 3x equals negative 10x plus 6 plus 3, and true for no values.
True for no values. Let's test it out. Okay, so let's combine our terms here. So we have a 5 and a negative 9. And what does that combine to?
-4.
Negative 4.
Oh, wait.
What do you think? What if I combine my other
I
side?
did it wrong. No, it would go in the true for all.
True for all, because when I combine my negative 10 and my negative 6, or my positive 6, I get a negative 4 plus 3x. And then my other side, these combine to negative 4 plus 3x. Nice catch, Abby. Perfect. So we would actually move this guy over to infinitely many solutions. Good. True for all values. Let me clear this ink. Who can help me make another match here? Of the ones that are left, what were some other matches that we made? Maybe somebody at home? Tyler, do you have one? Which one?
Y times -6 times -3 goes into the infinite.
Infinite? Okay, let's test it out. Let's see why. Help me out with this. How would I combine here?